We're talking about applying exponent laws here in section 4.6, Foundations of Math 10. And the beginning activity here is to evaluate this expression right here, and that is find a number answer. That's what evaluate means. So if you ever see that on a test or a quiz or in your textbook, that's what it means. Evaluate means find a number answer. And I want you to substitute a equals -3 and b is 2. So find a number answer here. When you're done that, I want you to compare your answer with someone nearby you, and also compare your strategy and how you figure this out with someone nearby you as well. Okay, so I'll give you a couple minutes to do that. All right, you guys can look up here. I wonder how many of you started to evaluate this like I did down here, method 1. Okay, how many of you plugged these numbers right into the direct expression? Okay, that would be most of you. I came around and looked. Most of you did this. The problem you get into here is that these are some really, really large numbers. And I also asked you to write the answer not in decimal form, but in fraction form, irrational form. So this is virtually impossible without a calculator. You actually don't need a calculator to solve this problem, to evaluate. You don't need a calculator, and I'll show you why in a second. But if you get to this point, it's virtually impossible to try and find a number that divides into both of these and try and simplify it. It takes forever. Plus, then you have to square it and everything like that. So this method, if you started on this method, you would need your calculator to do a lot of the work for you. What I'm going to show you now, method 2, this is the most direct method that, and I saw a couple of you did this the first time. I saw a couple of you got around to it the second time. But if we look at method 2, what I want you to notice here is that inside the brackets, and we'll focus inside the brackets first, is that you have a division of like base variables. All right? And you guys know from your exponent laws from last year that when you have the same base and you divide, what can you just do to the exponents? You can just subtract the exponents. So what I am suggesting, instead of plugging numbers in first, look inside here to see how you might simplify this. And this is what it would look like. A to the 6 divided by a to the 5 is a to the 6 minus 5, which is a to the 1, or just a. You just write a. So this simplifies to a. What about b to the 9 divided by b to the 8? That simplifies to b to the 9 minus 8, or b. So inside the brackets, do you see how we have simplified this into this? And what we're doing is we're using the exponent laws in this method too. And so that's what we're learning about. We're learning how to apply the exponent laws. And so this is a much simpler problem to solve, and you don't actually need a calculator at all to do this, right? Now, do you remember what other set of rules we would use to evaluate expressions that have multiple operations? I'll say that again. Do you know what rules we use? Yeah, you said it, BEDMAS. Remember BEDMAS? Anybody remember BEDMAS? B-E-D-M-A-S. Now, what did BEDMAS help us with? The order of operations. Very good. So if we review that, this is why I started inside the brackets first. That's why. Because B is listed first in BEDMAS. So when you're talking about evaluating something that has, maybe some multiplication, some division, exponents, brackets, you look to this, BEDMAS. This is brackets. Just as a quick review. E stands for exponents, yes. D, division. M, multiplication. A, addition. S, subtraction. Now, the interesting thing about this is that, I don't know if you remember this, but division, multiplication, there really is no, there isn't one that you need to do before the other. What you do is you do whatever comes first, left to right. So division and multiplication are sort of on the same footing, and same with addition, subtraction. Really, whichever one comes first from left to right, you can do either. But they have to go in this order. Brackets first, exponents second, division and multiplication third, and addition and subtraction fourth. So I looked inside the brackets to see what I could simplify. And even down here, right, before I applied the exponent, I did some simplification in here. This isn't the most efficient method, but I followed the order of operations. Okay, so now I can substitute here, and what do we say a was? -3, b is 2. All right, to the power of -2. So inside the brackets, let's simplify this to -6. After the brackets have all been taken care of and simplified, now I look to e, which is exponent. So let's apply the exponent. If it's a negative exponent, what can we do to get rid of that negative? Take the reciprocal, right? So this becomes a 1 over -6. And then that too becomes positive. So that's what we just learned in the last lesson. And at this point, squaring -1/6 is pretty easy. That's 1 over 36. And again, that's with no calculator. You avoid all of this mess right here. Look at that, brutal. How do you simplify that? So using the exponent laws will help us to evaluate things quicker, help us to simplify more complicated problems. Okay, so let's now go over the exponent laws. I know you all should know them, but let's write down the exponent laws here. The first one, and these are on page 237, and yes, I do want you to write them in your notes so that you actually physically, write them out, spend some time, let your brain and eyes and brain absorb all this stuff, okay? So product of powers. So product means multiplication. Powers have a base and an exponent. So product of powers. And this one pretty pretty well, I think. If you have a product that's multiplication and you have like bases, then the rule here is that you simply add the exponents up. That's the product of powers. The quotient of powers would look like this. Quotient means division. So the quotient of powers, if you have like bases, again, the base has to be exactly the same, but then what you can simply do is, and you guys mentioned this before, subtract the exponents. Always start with the top one and subtract the bottom one. So that's the quotient of powers. The third one is power of a power. So if you have a power like a to the m, and you take it to another exponent, so an exponent raised to another exponent, a power of a power, then the rule is, who remembers that? Add, subtract, multiply, divide. What? Multiply. Yes, so it's m times n. Power raised to a power, you multiply exponents. A lot of students get these ones mixed up. This one and this one. They multiply here because they see multiply, and they add here because they're so close together. So don't get those mixed up, okay? The power of a product. Okay, so if we have a times b to the power of m, then, and this is actually really important. If these are factors, a times b in here, not a plus b, it doesn't work for a plus b or a minus b, but only for a times b, then this is the case. We can actually separate and we can do this. The m, or the exponent, can be applied to each factor, and that's the power of the product. The final one that we'll talk about today is the power of a quotient. So just like a product, if we have a divided by b, and that's to some power, to some exponent m, that is the same as the exponent being applied to the numerator, as the top, and the denominator, the bottom. Now, it's important to note that b can't be equal to 0. Remember, we can't divide by 0 or 0 to any power. So if b is 0, we've got issues, right? That's no good. You cannot divide by 0, and you can't take the square root of a negative number, right? Or an even root of a negative number. These are kind of things that you know are alarm bells in math, right? The answers are not real. They're undefined. Okay, but those are your exponent laws, and these are the ones we're going to be exploring and using today. So just take a moment to absorb that. Copy all those down. So we're going to couple these rules with, of course, BEDMAS, which we talked about before already. And we're going to evaluate some pretty complicated powers, all right, or simplify. Anyways, remember, evaluate means we need a number answer, and simplify means we just need to use any simplification rules or get it down to the sort of its most basic form, right? So, for example, let's do this one here. X cubed y squared times x squared y to the negative fourth. So if we were asked to simplify this, example 1, we are multiplying, right? Is there anything inside the brackets we can simplify first? So any variables with the same base that are added or multiplied, or anything we can simplify inside each of these brackets first? No. Brackets, there's nothing inside the brackets, so we don't have to do anything. Are there any powers that we should evaluate or simplify? Well, there's powers on the variables, but what can we do with this? X cubed, how can we simplify that? Or no. What we're going to look at now is the division and multiplication, okay? Because you're right, we have a product here, and of course we can rewrite this, really, if we want, and you don't have to, but I'm just going to show you that you can. You can rewrite this as x times y squared times x squared times y to the negative fourth. These brackets don't really mean much because they are all multiplied together anyways. If this is the case, it doesn't matter which ones you multiply first and which ones you multiply second. So I would suggest that you think about this, x cubed times x squared. So put the x's together and put the y's together. Again, you do not have to show all of these steps. I'm just sort of trying to help you understand this in your mind, all right? So I'm showing every possible step here to try and communicate what I'm trying to communicate. But at this point, now you can see that, hey, we have a like variable, same variable, that are multiplied together. And as well over here, the same base. So the simplification process looks like this. What do we do with these? Add, subtract, multiply, or divide. Which one? Add. Very good. So this is x to the 3 plus 2. And then y over here to the 2 plus negative 4. So again, showing you every single step here. So this is x to the 5. And this is going to be y to the what? What's 2 plus negative 4? Yeah, negative 2. Right there. Now, you would be okay to stop here at this point. But I'm going to let you in on a little secret. Normally, simplifying means not leaving any negative exponents. So we should go one more step here. And how would I get rid of this negative exponent? What would I have to do to show that as positive? Reciprocal. Yes, reciprocal is the word. Now, I don't have to do anything with this one. But this one right here, I'm going to bring down into the denominator. So this is going to become x to the 5th divided by y squared. And there is your simplified answer. So here's example 2. We'll simplify this. Now, it's important to note that we have definite sections here of factors. So remember, this is 10 times a to the 5th times b to the 3rd. This is 2 times a squared times b to the negative 2. So we have definite sections here. You see that we have coefficients here, or actual numbers. We have a variable, and we have the b variable. So we have separate sections. Now, there's no brackets. The exponents, well, we're not really dealing with individual exponents here. Division and multiplication. Well, this is a division problem, right? So we can do the dividing, and we can simplify this. So watch this. This 10 over 2 can be simplified, can it? What can that be simplified into? 5, and I'm going to put it over 1 right now, yeah. 10 over 2 simplified to 5 over 1. What about a to the 5th divided by a squared? Well, let me just show it to you this way. I haven't showed you this this visual before, but a to the fifth literally means a times itself 5 times, right? A squared means a times itself 2 times. So if you're wondering how to simplify that, or why we subtract the exponents, if you're wondering why we do that, check this out. A divided by a is just 1, right? So those really divide out to give you 1. They're gone. There's another a up here that can divide with this other a down here. Those are gone. So what's left? A times a times a in the numerator, which is a to the positive 3. See that? So a to the fifth divided by a squared is a to the positive 3, so we put that 3 in the numerator. Now it's a little tougher to visualize this, but I'll do it here for you. So we have b times b times b divided by b to the negative 2, or 1 over b times b. Now, how do we simplify this? When you divide by a fraction, do you remember what rule you follow when you divide by a fraction? What do you do? When you divide by a fraction, I'm add what? Well, no, you only add the exponents if the one on the bottom is negative. The question is, what's the rule when you divide by a fraction? Blank and blank, blank, blank. Blank and blanky blank. Flip and, thank you. Anybody remember this little rule? Flip and multiply. Did you just guess that? Really? You guys never heard this before? When you divide by a fraction, you don't remember that? Flip, multiply? Really? Serious? Like 1/3 divided by 1/8? You don't remember how to do that? Come on. Yes, you've been taught this, absolutely for sure. You take this in the bottom and you flip it. That means you take the reciprocal and you multiply. So this becomes 1/3 times 8 over 1. Those are the exact same. Just the one on the bottom, yeah. So 1/3 divided by 1/8 is 8 over 3. You flip the one on the bottom and you multiply it by what's on top. Okay? Guaranteed you've heard that before. Maybe you don't remember it. That's fine. But anyways, watch this. This is why I brought that up, because we have a fraction on the bottom here, right? So in order to view it this way, we would flip and multiply. So that's b times b times b times b times b over 1, which is b to the power of 5. Now that's why we subtract, and that's why you get 5 when you go b to the power of 3 minus negative 2. See that? If it's a negative, you end up adding 3 plus 2. b to the 5th. Make sense? I'm seeing a lot of confused looks, but what you're going to have to do is go over this in your book, watch this video again, whatever you need to do. But that's why we subtract, and this is another representation of b cubed divided by b to the negative 2. So, as I continue, no, sorry. There you go. Magico. Okay, got that down now? Okay, there we go. It's going bye-bye. See you. Alright, so we got b to the positive 5, right? B to the positive 5. So, where does positive go? That means it's in the numerator. So what do we have? We have 5a cubed b to the 5th. That's about as messy as I can draw there. 5, 3. Capiche? Understando? You got it? This is the final answer, yeah. Yeah, that's simplified version. You can't do any more simplification there, yeah. That's that. Alright, you guys ready for a tough one, or? Okay, I'm going to give you one. I'm going to give you one to do on your own here. Let's see if you can do it. Okay, no looking this up in the textbook. Try and do this on your own. So this is 4a to the negative 2b to the 2/3 divided by 2a squared b to the 1/3. Okay, go ahead and take a minute to do that. Okay, use your exponent laws to simplify this bad boy up here. Two over three. Alright, so if we take a look at the answer here real quickly, 4 over 2 is 2. A to the negative 2 divided by a squared, you subtract those two to get a to the negative 4. Subtract the fractions there. 2/3 minus 1/3, 2 minus 1 is 1. So that's b to the 1/3. This factor goes down to the denominator to become positive. And if it's in rational form, then you would write b to the 1/3 as cube root b. So 2 cube root b over a to the 4th. Okay? Question? Yeah, so just to clarify, here's your answer in radical form. There was a question about the 1/2 here. This is negative 1/2 in the denominator, so I brought it up to the numerator and made it positive 1/2. After I did the subtraction here, 1a to the 1 minus 5, this is a negative 4, so I took that down to the denominator to make that positive. At whatever step you do, those doesn't matter, but this is what you should end up with. Now, the other little bit of a tricky thing is remember that, and this is just the way I did it, right? You could do it different ways, but this is the best way, and this is what what I've been modeling for you consistently here. But this 1/2 can be applied to each factor, remember? Each factor in the numerator and the denominator. So 4 to the 1/2 is 2. B to the 1/2 to the power of 1/2, that's when you multiply. And then a to the 4 to the power of 1/2, multiply down there as well. The 4 to the power of 1/2 is the same as the square root of 4, which turns into 2. Well, the 4 is negative here in the numerator. I moved it down to the denominator down here, and that changes the sign. Well, it's a factor. How do you do that? You know what? It's a factor with a negative exponent, so you can just, because remember this, a to the negative 4 is the same as 1 over a to the positive 4. Remember that? So this is the exact same as this. When it's in the numerator, it's like over 1. When it's in the denominator, it's like 1 over. So really, they're the exact same. So could you No, you can't choose which one you want to move down because this one is positive in the numerator and you want to leave the exponents positive. So you want to, because in the end you want positive exponents. Yeah. Yeah. Now, as you move through math, okay, you may see this as a valid answer. Boom, done. So don't say, oh, that should be positive. Well, yes, to simplify, this should be written as a positive. But when you get up into upper levels of math, they're not going to care about the little rules where how you show this answer, because you're supposed to know, and everyone that's looking at your work knows what this means. Right now, part of the simplification process that you have to learn is to put this in the denominator to make it positive. Okay, okay, good questions. I'll give you your assignment here now.